Hello there, Mr. Sutton here, bringing you the IM3 Chapter 7 Quiz 1 Review Solutions on Right Triangle Trigonometry. So for this problem, and really any problem where we know two sides of a right triangle, we can always find the third side using the Pythagorean Theorem. That's a squared plus b squared equals c squared. Now, the key to plugging things into this is recognizing that c is the hypotenuse, the longest side of the right triangle, and that's always across from the right angle. So in this case, our c value would have to be 14 because that's across from the right angle. So that means that a and b are going to be 7 and x. And it doesn't matter which one is a and which one is b. It'll come out to the same thing in the end. So I'm going to use a for 7. So we'll have 7 squared plus, for b I'll use x, so x squared equals my hypotenuse of 14 squared. And at this point we need to get x squared by itself. So I've got 14 squared minus the 7 squared. Let me do that on the calculator. So plugging that in, that comes out to 147. All right. So we have x squared equals 147. Now 147 is not a perfect square. The closest perfect square is 144. That would give us 12, but so this is going to be 12 point something, but they wanted simplest radical form. So for that, when I'm splitting this up, when I square root it, I need to find the biggest perfect square that goes into 147. So it turns out that that is going to be 49, and you might have to try a few before you find one that works. But 49 times 3, because 50 times 3 would be 150, so 49 times 3 is 147. So when I square root both sides, I can write x equals the square root of 49 times the square root of 3, and then square rooting the 49, that gives us 7 radical 3. Given three sides of a triangle, to determine if it's a right triangle, we have to use the Pythagorean Theorem. So that, again, is a squared plus b squared equals c squared. So we basically just plug the three sides into the theorem and see if it actually comes out equal on both sides. So when you're doing this, remember that c is the longest side of the triangle. It's the hypotenuse. So these happen to be written in increasing order, but if they weren't, we would always plug the biggest number in for c, and then the other two numbers would go in for a and b. So I'm going to write 10 squared plus 24 squared equals, and this is going to be kind of a question mark, 26 squared? Well, we don't know for sure. I'm going to use the calculator, though, to evaluate each side separately. So here on my calculator, I've plugged in the left side of the equation, and if we do 10 squared plus 24 squared, that comes out to 676. Now let's go back to the calculator and do 26 squared. See what that comes out to. Might come out to the same thing. Yep, it does. So I'm going to write that 676 equals 676. Therefore, because these two are the same and these sides satisfy the Pythagorean theorem, we can say that yes, this is going to be a right triangle. Now, if these had come out to different numbers, we would write does not equals, and we would say no, it's not a right triangle. For this problem, we're trying to find the area of this figure. Now, if you're trying to find the area of a triangle, in general, you need the base and the height, because you're going to use 1/2 base times height for the area formula. If you're missing the base or the height, like in this problem we're missing the height, then if it's a right triangle, you can use Pythagorean theorem to find that missing dimension. So I'm going to start this by labeling that missing height as h, so I can refer to it easily. And now to find h, that'll be my first step before I even think about finding the area. So we have a squared plus b squared equals c squared, my Pythagorean theorem. And then the c value, that's the hypotenuse, that's this 9 across from the right angle. So the other two sides are a and b. I'll write 7 squared plus h squared equals 9 squared. And let's see here, 9 squared is 81, 7 squared is 49. To get h squared by itself, I have to subtract the 7 squared. So 81 minus 49, that's going to come out to 32. So that's what h squared equals. Now eventually I'm going to have to get the area in simplest radical form. So I'm going to go ahead and put this in simplest radical form after I square root both sides. So I can write h equals, and now the biggest perfect square that goes into 32 is 16. 16 times 2. So we've got the square root of 16 times the square root of 2. So that simplifies then to 4 radical 2. So that's my height. So now in general, we said area of a triangle is 1/2 base times height. So that's going to be 1/2 times the base of 7 times the height that we just found of 4 radical 2. And we can multiply these three things in any order. So I'm going to do 1/2 times 4, which gives me 2. So I've got 7 times 2 radical 2, giving me an area of 14 radical 2. And we got to be careful. If there were units on this problem, like, for example, this was inches, then our answer would have units of inches squared or something squared. On this example, we see that we have a right triangle with one side given and one angle. And it happens to be one of our special angles that we're looking out for, either 30, 45, or 60, 45 in this case. So first thing I'm going to do is just finish off the triangle here. If I've used up 45 degrees here, that means I've got 45 degrees over here because there was 90 left over after using this right angle. And this tells me that I have a 45, 45, 90 triangle. So once I've identified that, I'm going to write the ratio of sides for this, which is always s, s, and s radical 2. So, and then I'm going to actually go ahead and label the diagram here with these different s expressions. So I've written these ratios under the angle that they're across from. So for example, these s's are across from the 45 degree angles. So we have an s up here across from this 45 degree angle, and the other s is over here across from the other 45 degree angle. And then the s radical 2, that's always across from the right angle, so that's down here. Okay? So at this point, once you've matched those up with the different sides of the triangle, we need to find the value of s. Because if we find the value of s, we can then figure out x and y in terms of s. So to do this, I need to figure out which side they actually gave me a number for. In this case, that was this 2 radical 3 they gave me for the hypotenuse. So whatever side I have the constant for, I'm going to set the s expression for that side equal to that number, and that will give me an equation I can use to solve for s. So in this case, I see that s radical 2 and 2 radical 3 are the same thing. So I can write s radical 2 equals 2 radical 3. And at this point, I just have to solve for s. So to do that, I have to divide both sides by radical 2. So I've got s equals 2 radical 3 over radical 2. And they want simplest radical form for the answers at the end, so I might as well just turn this into simplest radical form now so that I don't have to do it later. So to do that, I have to get this radical 2 out of the denominator. I can do that by multiplying by radical 2 over itself. That will give me 2 radical 6 over just plain old 2. And then it looks like these 2's are going to cancel, so radical 6 is my s value. Once I have the value of s, I go back here and I see what those variables are in terms of s. So it looks like that x and y actually are both s. So just to write this quickly, I can say that x equals y and that they both equal s, which is to say they both equal radical 6. For this problem, I see that I have one side of a right triangle and one angle. It happens to be a special angle, 60. Let me just find the other missing angle here. If I've used up 90 here and 60 here, that leaves 30 for this other angle. So this is a 30, 60, 90 triangle. Once I see that, I go ahead and write out the ratio for that, the ratio of the sides. So that's always s, s radical 3, and 2s. And I'm going to label the diagram with those different expressions. So the s is always across from the 30 degrees, so that's here on this right side. S radical 3 is always across from 60, so that's going to be down here next to the 18. And then 2s is always across from the right angle, so that's going to be here on the hypotenuse. Now once I've done that, I need to find the value of s, because if I know what s is, then I know that x and y can be found as well. So for finding s, I need to figure out the side that they actually gave me and set the s expression equal to that. In this case, they told me the 18 here went with this side of the triangle, and I know that that's the s radical 3 side of this triangle. So I can write s radical 3 equals 18. I could also write x equals 2s, but then I can't really solve for anything. So I need an actual number here. But now that I have this equation, I can solve for s by dividing by radical 3. So we have 18 over radical 3 for s. And since our final answers need to be in simplest radical form, I might as well simplify this radical right now so I don't have to do it later. So multiplying by radical 3 over itself, I have 18 radical 3 over 3, which I can reduce. Since 18 divided by 3 is 6, I can reduce this to 6 radical 3. All right, well, I found s. Now I go back and figure out what x and y equal using that value of s. So we said here that x equals 2s because that's the 2s side of the triangle. So that means that x equals 2 times that s value of 6 radical 3. So that means x equals 12 radical 3. So 1 down, 1 to go. Now y, it looks like, we labeled with the s expression. So y equals whatever s is. And fortunately, we already found s up here. We found that it was 6 radical 3. So that is also the value of y. For this triangle, I notice I've got a right triangle with 45 degrees, so that means the other angle is also 45, making this a 45, 45, 90 triangle. So that means the ratio is going to be s, s, and s radical 2 for this. Let me go ahead and label my triangle with each of those now. The s's, as always, are across from the 45 degrees, so we have s and s for those two sides, and then this last side here is the s radical 2, always across from 90. Looking at the info they gave me this 2 radical 3 side, and that equates to this s expression. So that means that I can write literally s equals 2 radical 3. Now that I know the value of s, I can go ahead and figure out the x and the y that they actually wanted me to find. So for x, that's equivalent to s as well. So that will have a value of 2 radical 3. And for y, that's equivalent to s radical 2. So I have to take this s value of 2 radical 3 and multiply that by a radical 2 to get my y value. So the radicals actually end up getting multiplied together on this one. This is going to give us 2 radical 6. On this one, I have a right triangle with 60 degrees, so my other angle here is 30, making this a 30, 60, 90 right triangle, whose ratios are going to be s, s radical 3, and 2s. Let me label the triangle with each of those. S goes across from my 30 degrees up here near the 18. S radical 3 is across from the 60 degrees, so that's this x side. And then finally the 2s goes across from the 90 degrees, so that's the y side. So the info they gave me was this 18 side. Since that's equivalent to my s part of my ratio, I can write s equals 18. And now that I know s, I got that pretty quickly, I can go ahead and plug that in to figure out x and y. X we see is s radical 3. So that means we really have 18 radical 3 for x. And then for y, that's going to be 2s. So 2 times the 18 that I found for s, which gives me 36. On this triangle, I know that since I've got 60 and 90 degrees, I've got 30 over here. So this is a 30, 60, 90 triangle. That means the sides are going to be s, s radical 3, and 2s for the magic ratio here. And s is always across from 30 degrees, so it's this x side this time around. S radical 3 goes across from 60, so that's the y side. And 2s is always my hypotenuse for these types of triangles. Since I know that this side equals 18, and I know that that's the 2s side of this triangle, I can write 2s equals 18. Dividing by 2, I have an s value now of 9. And now that I know s, I can figure out x and y. Now x is pretty easy. That's just whatever s is. So we can say that x equals 9. Now for the y value, that's going to be equivalent to s radical 3. So that means we're going to have 9 radical 3 for the y value, and that's all I needed to find on this one.